So now we're going to graph these logarithmic functions, right? Remember, logarithms and exponentials, they're inverse functions, so they kind of cancel each other out. And we're going to go back to graphing exponential to graph our logarithms, and we'll explain that in a minute. So our parent function is just log base b of x, right? We have this similar curve, it's just kind of going in a different direction than our exponential, but it's still that same kind of curve, right? They're very similar. So we want to graph the function log base 3 of x. Okay, the first thing we're going to do every time we graph a logarithm is find the inverse, put it in exponential form. So to remember, to find the inverse, we switch our x and y and solve for y. So we get x equals log base 3 of y. So I want to get y by itself, and to do that, I'm going to put it in exponential form. So I start with my base. So I have 3, go around the world, to the x, and then back, equals y. So my equation is y equals 3 to the x. Well, to graph an exponential, I'm going to make my table of my parent function, which in this case is just 3 to the x. There's no h and k. And I'm going to plug in my points. So 3 to the negative 2 is 1/9. 3 to the negative 1 is 1/3. Anything to the 0 power is 1. And then to the first is 3. To the second is 9. So here's my exponential equation. But remember, I switched my x and y in the beginning, so to go from exponential to logarithm, I'm going to switch it back. So I'm going to take this same table and just switch my x's and my y. So the first point becomes 1/9, negative 2, 1/3, negative 1, 1, 0, 3, 1, and 9, 2. Now this is the table for my logarithm. So when I go to graph, we're going to go over, so 1, 2, 3. We're going to go over 1/9 and then down, that's that one, down 2, which is right about there. Then over 1/3, down 1, and then 1, 0, and then 3, 1, 4, 5, 6, 7, 8, 9, 2. And we will connect to make our curve. Alright, so put it in exponential form, make your table like we've been doing, then switch your table, graph your logarithm. So for this example, I've got log base 1/4 of x. So if I switch it, we've got x equals log base 1/4 of y. Start with my base, go around the world, and back. So now I've got 1/4 to the x. This is what I'm going to graph or make my table for my exponential. Alright, 1/4 to the negative 2 is 16. 1/4 to the negative 1 is 4. To the 0 is 1. To the first is 1/4. And to the second is 1/16. Then to go back to logarithm, I just switch that table. So we've got 16, negative 2, 4, negative 1, 1, 0, 1/4, 1, 1/16, 2. Alright, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, negative 2, 4, negative 1, 1, 0, oh, that's 2. 1/4, 1, and a little closer at 1/16. There's our curve. Okay, for this example, I'm just matching it to the correct graph. So again, we've got x equals log base 5 of y. Start with my 5, around the world, and back. Alright, so if I make my table, 5 to the negative 2, 1/25. 5 to the negative 1, 1/5, 1, 5, 25. Alright, now my big numbers like 25 aren't going to be on my table, so we'll use the smaller ones, but switch it back. We got 1/25, negative 2, 1/5, negative 1, 1, 0, 5, 1, 25, 2. Alright, so if I look at some of these, I know I got 1, 0, and 5, 1. So 1, 0, 5, 1. So that one's not it. This one doesn't have 1, 0. This one doesn't have 1, 0. But here we got 1, 0, 5, 1. So that narrows us down to answer D. So that's if there's no translations or transformations to our graph, if it's just log of a base of x. Okay, we also look at our transformations with our same letters, A, H, and K. All right, so remember H is horizontal, and it's always going to be the opposite sign. K is vertical, and A is going to be our orientation and shape. All right, so if A is less than 0 or negative, it's reflected. And then if it's bigger than 1, it's stretched. Between 0 and 1, it's compressed. And it's always vertically for A. The way we're going to do this, just like we did with exponential, we ignore the H and the K. Okay, so this case, I only have a K out here, so I'm going to ignore it for now. And I'm going to come back to it. I know that that minus 1 for my K is going to take my graph and go down 1. Okay, but we're going to do that at the end. I'm going to start with this and again find my inverse. So we get x equals 1/3 log base 6 of x. Alright, now before I write it in exponential, I need it to be log of a base of x. So I'm going to take my 1/3 and move it to the other side, and to do that I'm going to multiply by 3. So that cancels, so I get 3x equals log base 6 of x. Start with my base, go around the world. So we've got 6 to the 3x equals, oop, that should be a y. Forgot to put my y in there. Equals y. So now I'm at 6 to the 3x. Alright, so I'm going to make my table for 6 to the 3x. Now, this is where it's going to get a little easier if I don't use those same 5 numbers. The reason being is because if I multiply it by 3, it could get kind of ugly when trying to find my numbers to plug into my table. So I'm going to plug in numbers that I know are going to cancel out with that 3, or make it easy to plug in with 3. So maybe instead of -2, I'm going to do -1/3, because I know that 1/3 times 3 is 1, and that'll make my numbers kind of easy. So I'll do -1/3. Right? 0's always easy. 1's always easy in this case. And then maybe I'll do a +1/3. Just something that's going to make my numbers easy to work with. Alright, so -1/3. 3 times -1/3 is just -1. 6 to the -1 is 1/6. 3 times 0 is 0. 6 to the 0 is 1. 3 times 1 is 3. 6 cubed is going to be 6 times 6 times 6, which is 216. And then 1/3 times 3 is 1. 6 to the first is just 6. And these should have been switched. That's my fault. 1/3 comes before 1. Alright, so I'm going to ignore that 216. That one's ginormous. And I'm just going to use the rest of my table. So if I flip it back to get my logarithm, I've got 1/6, -1/3, 1, 0, and then 6, 1/3. Alright, so if I go to my graph, we've got 1/6, which is right in here, -1/3. Alright, 1, 0, and 6, +1/3. Alright, so there's some points I can use. Now remember, this was for the parent function part. Here, I got to take all those points and go down 1. So if I go down 1, right about here, here, and here. Alright, connect my dots with that curve, and there's my graph. Okay, same thing, but now I'm going to ignore that +2 in there, and that's an H, so I'm going to come back to that, and that's going to tell me to move all of my points left 2. So if I find my inverse, we got x equals 4 times log base 1/3 to the y. Before I start with my base, got to get rid of this 4. So I'm going to divide by 4. I'm going to rewrite that as 1/4 times x. Now I start with my base and go around the world and back. So I've got 1/3 to the 1/4 x equals y. Okay, it's weird looking. I'm going to put that in parentheses just so it's easier to see. So I've got 1/3 to the 1/4 x. Right? 1/4 can get kind of messy, so I'm going to make sure when I plug in stuff on my table, I use numbers that are going to cancel out that 1/4. Alright, so maybe I'll do a -4. Because that's going to cancel it out. Again, 0. Anything times 0 is 0. And then maybe we'll do a +4. Because because that'll cancel out the 1/4. Just being smart with my numbers so that my table doesn't get really messy. So 1/4 times -4 is -1. 1/3 to the -1 is 3. 1/4 times 0 is 0. Anything to the 0 power is 1. And 1/4 times 4 is 1. 1/3 to the first is just 1/3. Alright, then we got to switch them. So my new table becomes 3, -4, 1, 0, 1/3, 4. So I'll graph those points. And 1/3, 4. And then I've got to take all of these points and go left 2. So we got 1, 2, it's right about there, there, and there. Okay, now remember, this is going to have to make that logarithm curve. If I try to graph this and do the curve that goes this way, it's not going to go through my points. So it's really going to be going down, like from top left to bottom right. And that 4, remember, that stretches it vertically. So that's why it's kind of pulled up instead of having the sharper curve. It kind of comes down more like so. That was very sloppy. But just remember, think about what your graph looks like. Don't be trying to draw a straight line through these points because a logarithmic function is not a line. Okay, so to graph a logarithm, put an exponential with your parent function, make a table, switch your table, and then apply your transformations.